Xbox Series X motherboard. Switch to the microscope and let's see what's going on. And this one. Oh yeah, they dorked that one up pretty good. See if I can get that on screen well for you. Yeah, they managed to dork that up pretty good. See if they did any damage over here. These are going to be pretty hard to pull the or damage the pins on, because they are structurally pretty strong, but the issue with HDMIs is not necessarily this structure. I mean, yeah, you're protecting the board with this, with what they do with this structure. You're protecting the board, but the problem with HDMIs is the pins being in the middle row, surrounded by plastic. That's very easy to damage. There's a reason why, you know, I don't like to give Apple a whole lot of credit, but there's a reason why they designed the lightning ports the way they designed them, because there's no row of pins. So if you're going to damage something, it's usually the charger, not the port. So they do still manage to damage the port somehow, but in most cases, in theory, you would think that would be a better design, and most of the time it is. You can't stop people from finding new ways to damage things though. So, I'll throw up my temperature while I set up my equipment. These, as always, these are my expected temperatures for the job. If something else pops up and I have to lower the speed, usually I won't change the temperatures. It'll be the airspeed that would change. So, but it does depend on the work that needs to be done. At this moment, I do not foresee having to change the temperature card, but it is always subject to change. We're going to do what we always do with these ports. We're going to flood it with low melt. Flood everything we can see anyway. There's lots of things on these ports that we cannot see. Actually, it reminds me, I kind of want to check and see if the yellow dot has been broken. And we are not lucky enough for the yellow dot to be broken. See if I can get that focus for you, that'd be cool. We had a little yellow dot in there. Every once in a while I get lucky and it gets snapped, but we're not that lucky today, which means this will be the challenging version of the Series X. That's alright. That's what they hire us for. Well floated in there, just suck it right up in there, buddy. More. As we decided to hit the ground plane, and it sucked up all the solder off the iron. Now, I don't know why I just cleaned that off. We're going to need more for the pins. Now you might say, with so much hidden stuff, why are you flooding it with low melt? Well, the important thing to do, you have to understand with pulling these ports, is you don't want to pull the pin pads. So, if you don't have to worry at all about them, because they're going to be molten, they are going to be wetted immediately, pretty much, while you're trying to remove this thing. All you have to worry about is the anchor pads and the hidden pads. I don't care if I pull a hidden pad. I don't want to, but it doesn't matter. I mean, a hidden pad is nothing. It's just a ground plane. But these, we don't want to pull. So, now, we're going to do everything in our power not to pull a hidden pad. That would not be good. That would be sloppy. Now, I'm going to have to put some weight down on this board, so you're not going to be able to see it from the top angle, and I apologize for that. But I need to put some upward pressure on this port to pull it, and I need something holding it down. I don't have a big board holder for this side of the board anyway. Alright, I think we are prepped. It's about as prepped as we're going to get. So, get our hot air rolling. Pull this guy. It will take patience, and you will have to take your time. We'll start by warming up the general area. And what I want to happen first, really, is just that. I want those pins to wet immediately. And then we're just going to kind of concentrate on getting a couple of these anchor points to start wetting. And then we'll move to the other side and try to get the other ones. I want to see some wetting, and these on this side tend to be the toughest, because that is a huge ground plane. I mean, the other side is a pretty big ground plane too. But so working our way around here. There are hidden joints under the port we have to worry about too. But the anchors are by far and the plastic are by far the most challenging. And we're getting the anchor points on the bottom already wet, but these top ones are still being stubborn. Okay, alright. We successfully broke the plastic. Finally. And we managed not to pull any of the anchor pads, which is good. And of course no pins were pulled because we used low melt on them. Sorry that the focus wasn't that great, but none of the pins were pulled because we used low melt on them. Those pads were wetted from the moments after we started, so they were never going to be an issue. And that's why I use it. Yes, it doesn't really help with the pull overall, but it does help protect the important part of the circuit. The stuff we don't want to damage under any circumstance. We don't want to damage anything, at all generally, but of the things we could possibly damage, these pads right here are the most important. So now we're going to Wick. I probably could have made these easier by putting some unleaded or something on them, but they're not that hard to wick anyway. These have low melt in them, so they shouldn't be too difficult. And we're using the proper size tip for wicking. At least these. But if you've seen any of my videos, you know I rarely change this tip for wicking. Even on a USB-C port, I am using this tip. The trick to wicking is to get lots of thermal transfer. Not only do you have to warm the board and the pads and the solder, you have to warm the wick. You're not going to do that with a fine tip, generally speaking. You can if you want to suffer for a while doing it, but I prefer to get it done quickly. My ideal scenario is to get this done and back to them before they close. So, 20 minutes trying to struggle getting solder out of holes. And I appear to be out of alcohol, which is not going to cost me the time that I said. Wicking. There's always something that's got to pop up and, you know, destroy your flow. The life of a repair guy. Or at least hinder it if it doesn't destroy it. Alright, let's tin these pads with some Kester 44 63 37 solder, leaded solder. Yes, I'm using a fine tip micro soldering iron on this. And that's the reason why I'm going in circular motion, so we get some heat transfer. Grab us a new port. Oh, that's right. I do like to forget to tin the hidden pads on these. You want to remember to do that. Okay. Now let's grab a port. And set it on down in here. Alright, we're going to do this very much like we do a Nintendo Switch port, in that we're going to flow it in. I need to flow the hidden joints and the pins, and the idea around this is going to be to heat up the board enough to wet the solder. Just being leaded, it won't take quite as long as it took to remove, and all we're trying to do is the pins and the hidden joints, but it's still going to take some patience. Now, I kind of want to get in and watch these pins. So I kind of want to concentrate in that area for the most part at the moment. Get that wetted. Once we see that wet, we'll zoom out and start kind of concentrating the other side. Make sure we get those hidden pads. Starting to see some. Okay. Concentrating in this area a bit. Where those hidden joints are. Alright. I'm hopeful, but we'll hold it down here. Let it dry. Okay, now I'm going to very delicately test the soundness of the port. If these are not soldered, it'll kind of wobble, but it seems fairly solid, so that's good. We got the hidden joints. And by lightly tap, I mean lightly tap. We're not putting a lot of pressure because the only thing holding them on is the hidden joints and the pins. You do not want to end up pulling pads just touching the port. Alright, let's test the viability of our flow in. Make sure everybody's solid down here. While the board is warm, if we have to reflow, that'd be a better time to do it. But it appears good. Awesome. I'm going to rapid cool this a little bit. Actually, no. I like it to stay pretty warm, even though it kind of interferes with the flux application. We know we soldered down the hidden joints and all the pins are connected. I'm not going to do any touch up on those. The fillets are good. And that's really going to be it for this repair. I'm going to clean it up off screen with my air compressor, and then return to the shop. If you have any questions about the equipment I use in it, well, in summary, we just had a broken HDMI port. And all we did was replace it. No big deal. Again, it's a little more challenging with these Series X's because of the plastic in there, as you saw. But it's pretty straightforward other than that. If you have any questions about the equipment I use in this video, take a look in the description below. Do me a favor, if you like this video, hit the like button. And if you want to see more like it, hit the subscribe button, notification bell. And you'll know when I post videos, which is about twice a week. If you have any questions, please post them down in the comments. I'll do my best to answer them. Or direct you somewhere that I think can answer them. You know, and if we've helped you with a repair, and I'm saying anybody in this repair community, if we've helped you repair your own stuff, do us all a favor and share your story somewhere. It would help the channel, and you know, it'd be a great favor to us in return for us helping you, and we'd all be very grateful. That's really all I have to ask of you. I appreciate your support. I appreciate you watching, and we'll see you in the next video.